Refrigerant 134A enters the condenser of a residential heat pump. So this is a heat pump problem. At 800 kilopascal and 35 degrees C at a rate of 0.018 kilogram per second and leaves at 800 kilopascal as a saturated liquid. So input to the condenser is given, let's call it in. Pressure is 800 kilopascal, temperature is given, and mass flow rate is also given, 0.018 kilogram per second of refrigerant. It leaves the condenser at 800 kilopascal and as a saturated liquid, quality is 0, or this is a saturated liquid, F. If the compressor consumes 1.2 kilowatt of power, W that in is given 1.2 kilowatt. Determine A, the COP of heat pump, and B, the rate of heat absorption from the outside air. So we see that the heat pump cycle consists of 4 components. If we look at the evaporator, we see that the evaporator absorbs heat from the outside air. So we are interested in this Q.L. COP of heat pump is equal to Q.H divided by W.net in. So if we take a look at the cycle, we see W.net input to the compressor is given 1.2 kilowatt. How about Q.H? I'm going to take condenser as the system to solve for Q.H. So we are going to take the condenser as the system, and I see that it is an open system. Refrigerant enters and leaves the condenser. And we know that this is a steady flow process. There is no change with time. So if I write down the first law of thermodynamics, for condenser, it's going to be E dot in is equal to E dot out. I know that in the condenser there is no heat input, we only have Q dot H, which is the output from condenser. There is no work interactions, and I'm going to assume that there is no change in kinetic energy and no change in potential energy. So left hand side will be M dot in, H in is equal to Q dot H plus M dot out, H out. Also from conservation of mass, for a steady flow process in the condenser, M dot in will be equal to M dot out, and I'm going to just call it mass flow rate of refrigerant. So I'm going to put this M dot of air into the first law and rearrange this for Q dot H because we're interested in Q dot H. So Q dot H will be equal to mass flow rate of refrigerant times H in minus H out. Mass flow rate of refrigerant is given in the problem statement, 0.018 kilogram per second. So I need to solve for H in and H out. Input to the condenser. Pressure and temperature are both given. Pressure is 800 kilopascal and temperature, let's call it in, temperature is 35 degrees C. So we need to determine the state. I'm going to go to table A12, pressure table for refrigerant. At the given pressure, I'm going to read Tsat. Tsat at 800 kilopascal is equal to 31.31 degrees C. Then I'm going to compare this number with T in. T in is greater than Tsat, so refrigerant enters the condenser as superheated vapor. I'm going to read for enthalpy. Enthalpy will be equal to 271.24 kilojoule per kilogram. And you need to make interpolation to get this number. Then for the output, pressure is given 800 kilopascal, and it is a saturated liquid. And it is a saturated liquid. So H out is equal to HF at given pressure, 800 kilopascal. Table A12, pressure table. It is going to be equal to 95.48 kilojoule per kilogram. So I have both these two numbers. I have mass flow rate of refrigerant. I'm going to plug in all the known into this equation and solve for Q dot H. Q dot H will be equal to 3.164 kilowatt. I am supposed to solve for COP of heat pump cycle. So this is the equation. Denominator is known. Now we just solved for numerator, 3.64 kilowatt. So COP of heat pump will be equal to 2.64, and we know that COP is unitless. So we just solved for COP. We are also interested in Q dot L, the amount of heat absorption from the outside air. So this time I'm going to take the entire cycle as my system. Entire heat pump cycle as the system, and write down the first law for it. Again, it's a steady flow system. E dot in is equal to E dot out. It's a closed system. So what energy gets to the system? Q dot L and W dot in enters the system, the cycle, and Q dot out H leaves the system. So Q dot L plus W dot in is equal to Q dot H. We know the number for W dot in, it's given in the problem statement, 1.2 kilowatt. We just solved for Q dot H. It is 3.164 kilowatt. So Q dot L will be equal to 1.96 kilowatt.